Alright, let's look at the quiz review for 4.3 to 4.5. So number one, given our function is x squared minus 2x plus 3, find the average value in the interval from 0 to 3. That's part A. And then part B, find the value of C guaranteed by the theorem. So our average value theorem is simply height is equal to definite integral divided by the width. So plug everything in. We know our A and B value. We know our function. So we simply have to evaluate x squared minus 2x plus 3, going through power rule. Okay, evaluate between our upper and lower bound. Plug in our upper bound first, and we get 27 over 3 minus 3 squared plus 9. Now the lower bound will cause every term to go to 0, so I just left that out. So this represents definite integral divided by the width, which is times 1/3. So we get 9 minus 9 plus 9, which is 9, divided by 3, which is 3. So we have our average value. Our average height is 3. So now we want to figure out when is this graph going to cross this this height, or this y value of 3. Okay, so we simply set them equal to each other. In this case, x squared minus 2x, the 3's cancel out, so we can simply factor out the x and solve for x. So x equals 0 and x equals 2. Okay, so c is equal to 2, but then we can also say that c is equal to 0, since we have the endpoints can be the c value. Okay, number 2, we have our function being secant squared x. Again, we want to find the average value, but now we're only asking to find the average value. So 1 over b minus a, definite integral from a to b of secant squared x. Secant squared becomes tangent x. Plug in our upper and lower bounds. So we get 2 over pi times 2, because tangent of pi over 4 is 1. Tangent of negative pi over 4 is going to be negative 1. So we get 2 over pi times 2 is simply 4 over pi, so we have our average height there. Okay. Number 3, okay, we want to find the derivative of this function that has an integral in it. So remember, we can use second theorem of calculus as long as our upper and lower bounds fit the criteria. So here in this case, lower bound is a constant, so that's fine. Upper bound is a variable. So our rule is simply that we can say if we want to find the derivative of the definite integral from a constant to a variable, SFTC. Then for the most part, these operations are going to cancel each other out, but we do have to make some adjustments with the upper bound. So plug the upper bound into the function. This function will largely remain unchanged, so f of p of x, but then this derivative is going to affect this p of x as well, so we have to say times p prime of x. Right? So if we follow that rule, then we can apply second theorem of calculus. Our upper and lower bounds fit the criteria. So plug upper bound in for all the t values, so negative 2x squared over 4 minus negative 2x squared cubed. Okay, that represents f of p of x times p prime of x. So negative 2x squared becomes negative 4x. So we combine this to get 8x cubed over 4 plus 8x is 6. Okay, we can factor out cancel out 4 to simplify it even further. Okay, number 4, we have 1 minus 2t. Our upper and lower bounds do not fit the criteria for second theorem of calculus, so we have to go through this with each of the operations. So we got to first take care of the integral, definite integral. After that, then we can find the derivative. So definite integral, we take care of 1 minus 2t, which turns into t minus 2t squared over 2, going through power rule. Plug in our upper and lower bound, upper bound first. So 3 root x minus 9x, that's f of b, minus, then plug in your lower bound, negative x minus x squared. Okay, combine all this, then this results in our definite integral, but we still have to find the derivative, so we go through power rule for derivative. So 3x to the 1/2 becomes 3x. The derivative should be going through power rule for derivative, so we should get 3 times 1/2 x to the negative 1/2 minus 8 plus 2x. Okay, and this reduces to be 3 over 2 root x minus 8 plus 2x. Okay, so we shouldn't be finding the integral, we should be finding the derivative. Okay, so 3 over 2 root x minus 8 plus 2x. Alright. Number 5. Let the definite integral from negative 3 to 6 of g of x be 10. From 3 to 0, g of x dx equals negative 4, which I'm going to go ahead and rewrite because we like to see definite integral with a lower bound being the smaller value. So if I flip this, I'm going to change this sign to be a 4. So I'm going to use this instead. Okay. Now what's given to us is our function is even. So we have an even function, meaning that our graph will be symmetrical on both sides of the y-axis. So from negative 3 to 6 is equal to 10. So negative 3 to 6 is equal to 10. But we also know that from 0 to 3 is equal to 4. So we know that this portion is 4. If we know this portion is 4, then we know that this portion must be equal to 4 as well. Okay. However, we know that this region is equal to 10. So if we know this is 4 and this is 4, then the remaining definite integral from 3 to 6 must be equal to 2 in order for us to fulfill this condition here. Okay. But if we have an even function, that means this left side must also be equal to 2. Okay, so here is a graph that would represent these situations. So now we want to find the definite integral from negative 6 to 3. So negative 6 to 3, we simply add the terms, add the definite integrals up. So 2 plus 4 plus 4 is simply equal to 10. Okay, part B. The conditions are the same, but now our function is odd. Right? So from 0 to 3 is 4. Okay. From negative 3 to 6 is equal to 10. Now, if we know this is positive 4, we know this must be negative 4. So if these three regions combine to be 10, this cancels out to be 0, so that means this region must be 10 in order for this condition to be true. Right? So negative 4 plus 4 is 0, plus 10 is equal to 10. But this is an odd function, so if this is positive 10, then the other side must be equal to negative 10. Right? Everything has to cancel out to be 0 if we're looking at bounds that are equal distance from the origin. So now we want to find the definite integral from 0 to 6. So from 0 to 6 is simply 4 plus 10, which is 14.